After all of that, I is equal to the integral of 1 over x dx minus the integral of x over x squared plus 1 dx minus the integral of x over x squared plus 1 squared dx. Does that look right to you? These two are zeros. Everybody? I got the first one. Y'all don't need to worry about that. This one is I1. This one is I2. And this one is I3. I1 is equal to log x plus c. Perfectly all right for me. It's obvious. If you want to write it down and then tell me that, that's better. But if you know that's what it is, what it has to be, just tell me. That's good enough. Okay? The next one, I2 is equal to the integral of x over x squared plus 1 dx. U is equal to x squared plus 1. Du is equal to 2x dx. So x dx is equal to 1/2 du. That means that I2, that equal sign, where it is right there, I understand. Nope, I don't have any questions at all. I understand that that equal sign goes with that one. You don't have to draw that arrow. You don't have to put I2. I know it goes with it. Okay? So now I have 1/2 times the integral of 1 over u du. Does it look that way to you? Which is 1/2 times the natural log of x squared plus 1 plus c. Do you agree? Now I3. I3 is, and now I is equal to I1 minus I2 minus I3, right? Everybody agree? I wrote it like that so I'd remember to put a negative in front of whatever I got for each integral, each of the last two. So I3 is equal to the integral and I let u be equal to x squared plus 1. Du is equal to 2x. One half du is equal to x dx. So now I3, you don't have to write it, I chose to this time, is equal to 1/2 times the integral of u to the minus 2 du. Does everybody agree? It's 1 over u squared, right? But I wrote it as minus 2 so I could add 1 to it, and you know the deal. So now I have 1/2 times minus u to the minus 1 plus c, which is minus 1/2 1/2 times x squared plus 1 plus c. Does all that look right to you? And now all I do is put them together, huh? Everybody agree? So, I have I is equal to log x minus 1/2 natural log x squared plus 1 plus 1/2 1/. And you know why the sign changed here, right? That negative up there. And this one changed to positive because I had a negative times that negative up there. Ed?
Yeah, you had one just like that, either on test 5 or the 5.
There is?
Well, when you gave it to us, I remember it was on
Yeah,
the
oh yeah. Yeah,
Yes,
yes. Expect that. Yes. Questions? The reason the book wanted to work this one is because it wanted to show you some tricks on how to make it. Let me get it on full screen so you can see it all at once. The reason the book won't work that one is because they wanted to show you some tricks on how to find A, B, and C. We didn't need their tricks. Questions, anybody? Okay. That's 5. 6 and 7 now look really, really easy. I'll do 8. This is example 8 on 478.
In the book, they took that answer a step further, but where we left it was good.
Fine with me. This is example 8, easy little old problem. And that is the I is equal to the integral of x minus 1 over x plus 1 cubed.
Is it third?
Okay? Like always, right? And that is x minus 1 over x plus 1 cubed is equal to a over x plus 1 plus c over x plus 1 to the third. Why didn't I put ax plus b anywhere?
Because the denominator is just x plus one.
Because what's inside the parentheses everywhere is x to the first power, right? And that's why I didn't need to do anything else. Okay? All right. Then we have x minus 1 is equal to a times x plus 1 squared plus b times x plus 1 plus c. Do you think that's right?
Yeah.
And if you don't think what I did's right, take it off to the side. Anybody have a question about any part of that? If you do, I'll work it for you. Anybody? All right, what's next?
Let x equal -1.
What's next?
Let x equal something.
I just refuse to make this hard. I just refuse to make this hard. And that is c is equal to minus 1. Nope.
I was going to set it to x minus.
No, I jumped the gun. Let's see. Wait a minute. I can't do it. I'm going to have constants. But, yes, I can too. I can let x be equal to minus 1. Then I have minus 2 is equal to 0 plus 0 plus c. So c is equal to minus 2. Okay? Now, if that's so, I can rewrite this as x minus 1 plus 2 is equal to ax squared plus 2ax plus a plus bx plus b. Everybody agree?
Where'd you get the +2 on the left side?
He brought the
You got
two.
I put a 2 right there, a minus 2 right there, and then when I moved it to the other side, it's a +2.
Mm-hmm.
So now I've got x plus 1 is equal to ax squared plus 2a plus b x plus a plus b. Is that right? Anybody got anything to tell me?
E equals 1.
What?
I would say
That a is
A plus
0.
B.
It's exactly right. A is equal to 0. Has to be, doesn't it? And then from here, I know that 1 is equal to a plus b. So, but that's 0. So b is equal to 1. where's the
I
problem?
just, I don't know, there's no X on the A plus B, so.
Do what now? I just didn't hear you.
How did you get A is equal to 0?
What's the coefficient of x squared on this side?
0 on this side.
On this side, the right side, what is it?
A?
The coefficient of x squared, what's the number in front of x squared?
A.
A. What's the number in front of x squared over here?
0.
So, doesn't the coefficient of x squared on this side have to equal the coefficient of x squared on this side? Therefore,
Okay. I keep forgetting to like stop looking at it, like algebraically kind of breaking it up.
all these problems break down if you find one and then take it out, don't they? They get a whole lot easier. And nobody in this world does it that way but me, but it sure looks easy.
So I've been with
Okay. And then the middle one you'd have.
The middle one I don't care about.
1 is equal, but if you were to do it, it'd be 1 is equal to 2A plus B X.
No, wouldn't I have, that's 0, and that's 1, so wouldn't I have 1x, which is exactly what I've got over here?
Okay, yeah.
But I don't care about it. All I want to do is find A, B, and C. And this method I would call living by your wits. Just thinking, huh? Question? To finish it. No. That isn't there, is it? That's 0, so that whole thing goes away, right? Plus B is 1. C is -2. And we'll call this I1, and we'll call this I2. I'm not either. I'm going to call this I2. And this I3, and say I1 is equal to 0 because A is equal to 0. Is that true? So now, for I1, I2 is equal to Everybody agree? Everybody agree? Add 1 to the exponent and divide by the exponent. Isn't that -1 over u plus c? which is equal to minus 1 over x plus 1 plus c. And I3, I'm sorry, I3 is equal to the integral of 1 over x plus 1 cubed dx, and I is equal to I2 minus 2I3. Okay, same thing. So I have then I3 is equal to the integral of u to the minus 3 du, which is equal to minus 2, equal minus 1 over 2u squared plus c, which is equal to minus 1 over 2 times x plus 1 squared plus c. Is that right? I did that pretty fast, is that right? You can't hardly see that negative.
C's a negative 2. Oh wait. I3's. Oh wait, you brought the negative 2 already out in I.
Yeah, I'm gonna go back to that negative 2 in a minute. I just wanted it out of my way. Look right there, buddy. Seth says okay. Bowers? Is that an okay maybe, Bowers?
Yeah.
Yeah, I brought the 2 with it. That's what I was.
Yeah, that's good.
But it's the same. It's the
Yeah,
same.
because
If all of that's true, then I is equal to minus 1 over x plus 1 minus 2 times 1 half times a minus 1 half x plus 1 squared plus c, and that's equal to minus 1 over x plus 1 plus 1 over x plus 1 squared plus c.
Hey Mo, I have a question about this test.
Yes.
We need to have any identities for this test 5, I guess?
That table of integrals, and now that whole table identities.
Well, I mean, it's integrated identities.
Oh, do you mean have any identities like trig identities? Ed, you didn't see one, did you?
No, not really.
I don't think so.
So this is all the card we need. Are we allowed card or just the?
Yeah, when I sent it up there, I sent it up there